To understand how antibiotics work, we need to break down their basic strategies, because not all antibiotics do the same job in general. There are two main types. One type stops bacteria from growing, and the other type kills bacteria directly. The first group, called bacteriostatic antibiotics, works more like slowing down the enemy. They block essential processes that bacteria need to multiply. Some of these antibiotics interrupt protein production inside bacterial cells. Without proteins, bacteria cannot build structures, cannot repair themselves, and cannot divide. Even though these drugs do not kill bacteria instantly, they give your immune system enough time to finish the fight. The second group, called bactericidal antibiotics, is more aggressive. They target critical structures, like the bacterial cell wall. Think of the cell wall as the armor around a bacterium. If that armor is damaged, the pressure inside the cell causes it to burst and the bacterium dies. Both types are essential, and doctors choose them carefully, based on the type of infection and the location inside the body. Inside whose trillions of microorganisms live together. Most of them are friendly. They help digest food, produce vitamins, regulate hormones, and protect us from harmful microbes. But here is the problem: antibiotics cannot tell which bacteria are good and which ones are harmful. They attack both. This is why some people experience diarrhea after taking antibiotics, because the helpful bacteria in the gut are also affected. That is why understanding these basics is important. Antibiotics are precise tools, not universal cures, and their strategies are designed based on the biology of bacterial cells. Now let us flip perspectives and look at antibiotics from the viewpoint of bacteria. Even though bacteria are tiny, their internal systems are incredibly detailed. Inside a single bacterium, there are protein factories, energy pathways, DNA repair systems, chemical messengers, and a network of processes running non-stop. If one key process is interrupted, the entire cell can collapse. Take cell wall synthesis, for example. Bacteria rely on a molecule called peptidoglycan to keep their walls strong. Penicillin and similar antibiotics block the enzymes that link pieces of this molecule together. Without those enzymes, the wall becomes weak, and when the bacterium tries to grow, the pressure inside causes it to burst. Another example is antibiotics that target ribosomes, the protein-building factories. Proteins are essential for every function inside a cell. Without them, nothing works. These antibiotics attach themselves to the ribosome and freeze the process of translating genetic code. Imagine a factory where the power suddenly goes out. Machines stop, workers stop, and production halts. That is what happens inside bacteria. When these antibiotics enter, scientists spent decades studying the tiny weaknesses inside bacterial systems to design antibiotics that strike at exactly the right spots. It is like knowing the blueprints of an enemy's base and finding the perfect locations to disable it. This is why doctors do not give antibiotics randomly. They consider what kind of bacteria is likely present where the infection is and which antibiotic fits the situation best. It is a targeted battle, not a guess. Now let us talk about something a lot of people get wrong. Antibiotics are often misused, and this misuse is one of the biggest threats to future healthcare. One of the most common mistakes is taking antibiotics for illnesses caused by viruses like the common cold, most sore throats, and many seasonal coughs. It does not matter how strong an antibiotic is, it simply cannot work against viruses. Viruses do not have cell walls, do not grow the same way, and do not use the same machinery. So giving antibiotics for viral infections is like trying to open a smartphone with a house key. It will not work. Another major mistake is stopping antibiotics too early. Many people stop taking them as soon as they feel better, but feeling better does not mean all bacteria are gone. Some survive, and these survivors can become stronger. This is how antibiotic resistance grows. Antibiotic resistance is a global crisis. Bacteria are evolving to resist medicines that used to kill them easily. When bacteria become resistant, doctors must use stronger drugs, more expensive drugs, or combinations of multiple drugs. Sometimes there are no effective options left. Imagine criminals in a city who keep learning how the police operate over time. They become harder to catch. That is what resistant bacteria do. If this continues, the world could return to the days before antibiotics, when simple infections were truly dangerous. This is why understanding antibiotics and using them responsibly is not just personal, it affects the entire world. To really understand why antibiotics must be protected, let us look at real cases from hospitals around the world. In many hospitals, doctors are treating infections that no longer respond to standard antibiotics. One of the most well-known is methicillin-resistant Staphylococcus aureus, also known as MRSA. This bacterium used to be easy to treat with common antibiotics, but over the years it learned how to survive them. Now it causes infections in wounds, lungs, and surgical sites that are much harder to treat. Patients sometimes need stronger antibiotics, longer hospital stays, and more aggressive treatments. Another example is tuberculosis. Tuberculosis was once controlled with several simple antibiotics, but misuse and incomplete treatments led to resistant strains. Some forms of tuberculosis today require a combination of medicines taken for many months with significant side effects. These real-world cases show how dangerous things can become if antibiotics lose their power. Research labs are racing to create new antibiotics, but bacteria evolve quickly, and keeping up is extremely difficult. This is why education matters. People need to understand that antibiotics are not casual medicines. They are life-saving tools that must be used carefully, so future generations still have working treatments. So now, after this long journey, let us connect everything we have learned. Antibiotics changed the world. They transformed medicine, saved countless lives, and allowed modern healthcare to advance. But their strength comes with responsibility. Antibiotics do not work on viruses. They have specific mechanisms designed only for bacteria. And if they are used incorrectly, bacteria can adapt and become resistant, putting the entire world at risk. Your immune system is strong, and antibiotics are backup tools used only when truly needed. Not every fever, not every cough, and not every sore throat needs antibiotics. The future of antibiotics depends on us, on how responsibly we use them, on the decisions we make when we get sick, and on our understanding of how powerful and delicate these medicines actually are. If we protect them, they will continue saving lives for generations to come. If you like content like this, hit the subscribe and like button to support this channel, and share this video with someone who needs this insight. When we talk about antibiotics, most people imagine them as tiny warriors firing lasers at bacteria. But the real battlefield is far more complicated and honestly far more fascinating than any sci-fi movie could ever show. Inside your body, every second, there is a silent war happening. Billions of bacteria are trying to survive, adapt, and sometimes accidentally cause chaos. And antibiotics, in the simplest sense, are tools that tilt the balance of that war back in your favor. To really understand how they work, we have to zoom in so close that each molecule looks like a skyscraper. Imagine a bacteria cell as a tiny factory town. It has walls to protect itself, workers producing proteins, machines copying DNA, and guards making sure everything stays organized. Antibiotics disrupt one of these core systems. And depending on the type of antibiotic, the sabotage looks very different. Some antibiotics go straight for the walls. They weaken the structure until the bacteria literally bursts. Others sneak into the protein factory and jam the machinery. Without proteins, bacteria cannot grow or divide. And some, the more clever ones, target the DNA copy system, preventing bacteria from multiplying at all. Now here is the interesting part. Antibiotics do not kill everything inside your body. They are actually very selective. There is a reason they only work on bacteria and not viruses. Viruses do not have their own factories, walls, or machinery. They hijack your cells instead. So antibiotics look for bacterial structures that human cells simply do not have. That is how they work without destroying your own body. But even though antibiotics work with amazing precision, bacteria are not passive. They are some of the most adaptable life forms on Earth. Every time bacteria divide, they create small genetic mistakes. Most mistakes mean nothing. But sometimes one of those mistakes accidentally gives them superpowers, like resisting an antibiotic meant to kill them. And when that happens, the battlefield changes. Your body now faces an enemy that has seen your weapon and figured out how to dodge it. This is how antibiotic resistance begins. Many people think bacteria mutate because they want to survive. But the truth is much stranger. They mutate because they cannot help it. Life is messy. Evolution is messy. But out of that randomness comes the rare mutation that lets a bacteria outsmart a drug. And when antibiotics are used too often or used the wrong way, those resistant bacteria spread faster than ever. They become the new dominant army on the battlefield. Understanding this invisible war is crucial because it shapes how we use antibiotics responsibly. Not just to cure, but to protect these incredible tools for future generations.